Electromagnetic energy is a natural form of energy carried by electric and magnetic fields. It's all around us. It's generated by the sun in the form of radio signals in the environment. Light is a form of electromagnetic energy. It's an important distinction made in the electromagnetic spectrum between those energies which are regarded as ionizing or non-ionizing. Ionization occurs when you've got sufficient energy in the signal to strip a molecule. If that molecule is part of genetic material, that can potentially be a trigger for cancer. And that's the sort of energy that people think of when they think of X-rays or the energies associated with nuclear facilities. It's important to distinguish between that form and non-ionizing energies. Radio signals are a form of non-ionizing energy, and as such they cannot directly affect genetic material. Their interactions are in other ways, and for radio signals it's primarily in terms of heating. If we look at the electromagnetic spectrum in total, we can start at the low frequency end with magnets that people may have in their home, with power lines and the power circuits that provide lighting and heating in people's homes. We then move into the broad range of frequencies termed radio signals, and this includes services such as AM radio, FM radio, TV, the services provided by mobile communications, satellite, and as we move up further into shorter range and higher data rate links. Above the radio portion of the spectrum, we first move into infrared, which is the heating effect that you get from an electric radiator, and then into visible light. As I mentioned before, light is a form of electromagnetic energy. Above the visible portion of the spectrum, we move into UV, ultraviolet. One of the concerns with UV is the potential for skin cancer, and that's because about midway through the UV portion of the spectrum, we move from non-ionizing energy into ionizing energy. Above the UV portion, we start to move into X-rays, gamma rays, and other more intense energies within the electromagnetic spectrum. So to recap, the electromagnetic spectrum is a band of naturally occurring energies. Different aspects of that band interact with matter in different ways. The important distinction is made between ionizing energy that can directly affect genetic material and non-ionizing, which cannot do that. Radio signals are a form of non-ionizing energy. And in terms of radio signals, they're a familiar application that have been in use for more than 100 years.